not CMOS, sorry, NMOS. This is NMOS. Sorry, NMOS. So essentially all this is a switch. I don't know if you guys ever did physics, but this is a switch. So when the input is 1, the switch is closed. When the input is 0, the switch is open. That's it. And then PMOS is a bit different. It's just a reverse way. So input, and then we're going to have output this side, 1 and 0. So this is a 1-to-1 relationship, essentially. And now if we just get the PMOS, the only difference is essentially that circle. Picture onto here for you guys. Yeah, so this is a PMOS. Now, essentially, let's see what happens. Let's draw our truth table again. We have our in and our out. I'm just going to split it down the middle. If we have 1 and 0, it's just the reverse way. So imagine our switch again. Close when it's 0. So this is what happens when the switch equals 0. And this is what happens when it's 1. So the switch opens when it's 1. Does that make sense? And so imagine this here. So forget this. This is a bit confusing. But just imagine this here. This is how our switch is going to be, either closed or open. And that's all this essentially is. This CMOS, this NMOS, sorry, and PMOS are essentially switches. And that's literally all there is to the NMOS and PMOS. But what gets complicated is when we have, if I just download this and I can just edit it direct onto it. Yeah, so let's just discuss that for a second. Let's see what happens in each case. Yeah, now I can write onto it direct. Sorry about the... I guess it's not really the smoothest session, but I do apologize for that. So, yeah, it's important that you know that the gate comes first, and always remember, if in doubt, source above drain. Always. The source will always be on top of the drain. So just think of it as I like to think of it as a waterfall or like a tap. Think of it like a tap. Water comes out here, and then the drain is at the bottom. That's how I like to think of it. So the water source, drain. Just so you guys don't forget. Okay. So yeah, remember these are just the switches. These are just representing our switches. So let's go. So which of the following gives a connection from X to Y when A is 0? So this is A. So we're saying that the connection between here is going to be open this way because it's 0. So remember, in a NMOS connection, 0 equals open, 1 equals closed, and PMOS, 0 equals closed, 1 goes to open. So we want it to be closed to make the connection. So it would be the PMOS. Number 2. Which of the following gives connection from X to Y if only if both A and B are high? Well, let's discuss this. So if so what is high? So high equals 1, low equals 0. Essentially, that's it. So let's say, what if they're both 1? So let's draw a little truth table. So if A and B is 1, what would our PMOS and C? So I'm just going to label this as NMOS, sorry. I keep saying CMOS. CMOS is completely different, and PMOS. So NMOS if A is 1 is going to be 1. PMOS if B is 1 is going to be 0. So when this is 0, this means that this is open. That means it cannot be this. So what about this? Now it's 1, so this connects here and this connects here. Okay, and now this one, well, look, we can come here, which will give us a connection, and we can come here, which can give us a connection. So that one could be an option. But, however, if you think about this one, even if this one we couldn't go to because it was a PMOS, we can always take this path. Does that make sense? So we can always take this path. So when you get parallel ones, just think of them as separate ones. So think of it as X, Y, and then X, Y. Sorry, it's a bit cramped. But yeah, so you can essentially take them as, two separate ones, which is quite useful, I think. So yeah, just remember, when you get parallel ones, you can just split them up into separate ones. The same with this one. How would you write this out? X. Sorry, I'm not very good at drawing these. Y. And then X. Y. Sorry, it went a bit off the page, but you guys can get it. So this way, it doesn't work, because this will equal 0, but we still have this ray, which will give us a connection. So we'll still get a connection this way. However, it's saying, which of the following gives a connection from X to Y if only if both A and B are high. So this one, it doesn't matter, so it can't be this one, and it can't be this one, so it has to be this one. Let's go to this one. Oh, yeah, sorry, that's just the answer. Next one. Which of the following gives a connection from X to Y if only if either A and B is low? So it's saying only if A and B are low, so like I said, our truth table. Maybe I just make it 4 bars to make it easier to read. So A, B, P, and N. So if A is 1, B is 1, P is gonna be no. Sorry. If they're both low, so it would just be 0. So 0, 0. P is gonna be 1, N is gonna be 1. No, I'm lying to you guys. I said 1. I meant no. Okay, and then yeah, it's so simple. It literally is. So just think of it like this. So I have the current going in. Is the switch closed here? Yes, so we can go up. Going up. Is the switch closed here? No, so this one does not work. Let's go up here. Is the switch closed here? Yes, we can go. Go up. Is the switch closed here? Yes, we can go. Yeah, I can repeat that. Okay, so let's go back to CMOS and NMOS for Nadia. Okay. I'm sorry, NMOS and PMOS. Yeah. So over here, if we think of it like this. Oh yeah, I'm definitely gonna explain the quiz questions. Don't worry, I got you. So over here, so this is what we call a switch, right? You know that from physics, right? This is a closed switch. This is a open switch. This is an open switch. So when this, so 1 corresponds to open, and 0 corresponds, sorry, I'm saying that wrong way. I'm thinking of PMOS. Closed switch, and this is an open switch. So in a closed switch, current can flow. Current cannot flow. And if we draw a truth table, So 1 will correspond to 1 and 0 will correspond to 0. So current can go through if the switch is closed, cannot go through if the switch is open. Does that make sense, Nadia? And then PMOS is just the opposite way around. So if we go to PMOS, I went too much down. So if we go to PMOS, it's the opposite way around. So PMOS, it's 0 goes to closed, 1 goes to open. So yeah, we're just following, and essentially we're just following these little paths. It's quite a simple concept once you grasp it. Yeah, so this one works, no problem. I'm happy to help you anytime. So we have so let's just draw this one out again. So we have X, we're gonna have our NMOS, Y, and then we have another path which is X, another one, and Y, and this is B, this is A. Yeah, NMOS and PMOS are opposite. That's really it to it. That's honestly, that's all there is to it. So we have, if A is gonna be 0, then this is not gonna work. If B is gonna be 0, this is not gonna work. So this means that there is no way for the current to travel if everything is low. So low equals 0, for those of you who missed it, and high equals 1. Next one. So let's go from the Y. Let's take this path. Well, is this going to be closed or open if we have a 0? So if it's a 0 and we have a PMOS, it's going to be a closed way so we can get there and there's connection. Over here, let's try it again. So come this way. Is it closed? Yes. And there's a connection. So there's connection both ways, essentially. However, the only reason why this is wrong is because it doesn't matter if A is 1 or 0. It doesn't matter if B is 1 or 0, as long as the other one is 0. We want it if only if either A or B is low. Oh, so this one is going to be right, because it doesn't matter if this one, only if either A and B is low. So one has to be positive and one has to be negative. Well, not negative, but 0. So 1 and 0. So this works if it's 1 and 0. This one does not work because they both have to be 0, and this one they have to be. You know, they worded this question weird, so it could be this one, or it could be this one. But I think it's only saying if if there's only one solution. They only want the one that has one solution, so then I would go for this one. But let's see if I'm wrong or right. I feel like it's a 50-50 chance. Oh yes, it is this one. You know what, yeah? They're all right, but it's the way the question is. Like, there's 3 potentials. Okay? 3 potentials. So we have this one. That could work. This one could work. And this one could work. This one can't work because we need to have a 1 and a 0, or a 0 and or a 1 and a 0. This one can work if it's 1 and if it's 0 and 1. This one can work if it's 1, 0, or 0, 1. This one can work if it's 0, 1, or 1, 0. So it could be either one of these 3, you know. But they say in it's this one because there's only one way to have it working. If it's 0 and 1 or 1 and 0. I don't know. It's just so strange. I don't like how they word these questions. Oh, I see, yeah. I'm not sure why they do. They're just vibing by themselves. Just allow it. We know how it works, and that's all that matters. Okay, so do you guys know what AND is? So these are just the rules for AND. So I recommend you guys learn the rules for AND, OR, XOR, and NOT. So let's go through this. let's see why this works. Okay, so let's say we have a equals 0, b equals 1. Let's follow this. So the way this works is it can either come from one side. So this is how it works. So this circuit, so this is where we're trying to get to. So we split this in half, right? We want the current to either come from this way or this way. So we want it to either come from here, the current from here, or we want the current to come from here. We don't want them both. If we have both, we short it out. If current comes from no ways, we get undefined. And we don't want either of those. So let's draw a truth table. Do you guys want to draw a truth table? Okay, let's see. So we're going to have A, B, and output. So we can either have 1 and 0, 1 and 0, and then let's have our little outputs there. Okay, so let's start with when A is 1 and B is 1. So when A is 1, can we go up this way? Well, when A is 1, nope, this way does not work. Does this way work when B is 1? Nope, that does not work. So we do not get any output from this side. Let's try this one. When A is 1, does it work? Yeah, we can follow it down. When B is 1, does it work? Yeah, and we can follow it down, and we have an output of the high, which is 1. And then we can have 1 and 0 and 0 and 1. Sorry, I didn't write down all the possibilities. Let's erase this. Let's go from this way. So let's say we have 0 and 0 now. So if this is 0, does it go? Yeah, we can cross and we can get an output. And it works this way too. So we get an output. Also, it doesn't matter if B doesn't work. We always have the path A to follow. And it doesn't matter if path A doesn't work because we can follow path B. So essentially, it doesn't, in a parallel circuit, it only matters if one path connects. Okay, so this is a parallel circuit, and it only matters if one half connects. Does that make sense, guys? I hope it makes sense. Let me just check. Does that make sense? Can you guys tell me if it makes sense or not? Understandable. Okay, that's chill. Yes. Okay. So let's go for 0 and 0. So we know that it connects this way. So we have one connection here. Let's see if it connects this way. So does it go? No. So we just know it's gonna be 0. So let's see 1 and 0. So let's say we have A is 1. Does it go? No. Let's see if B is 1. B is 0, sorry. Does it go? Yes, it goes. So we get an output this way, so we can say that it's coming up this way, but let's check the other way. Does it go if A is 1? Yes, we can go. And B is 0, so no, the connection stops here, so we only have output from the 0. So now we have 0 and 1, so let's try it that way. Let me just get rid of the stuff on here. So we have A and B, so let's say A is 0. Does we have a connection here? No. So we know that it's going to be not from that way. Let's try it this way. B is 1. Does it work here? No. Let's try the connection from A. 0. Yep, that works. Connection. So we're getting the output from 0. Now we know that we have 1, 0, 0, 0. Does that make sense? This is 1, 0, 0, 0. Let's check our logic for AND. Does it match? 1, 0, 0, 0. Yep, it matches. and that confirms that this is an AND gate. Does that make sense to you guys? And essentially, that's all you really need to know, is just like seeing how they work, to be honest, and finding, like, seeing how they connect and everything. This stuff doesn't come up in the quiz, so we can always cover it at a later date. I don't mind. But yeah, so these are just logic gates. Logic gates do come up, so just know the symbols. And essentially just do the logic. Let's say we had like a really complicated logic gate, like, let's look at the quiz. Let's go through this kind of question. Yeah, so this question. And so let's say we have I don't know, let's say we have A and B and we have output. Let's do this together. So 1 0 1 0 1. I'm sorry, I should do it the other way around. 0 1 1 0. And we're just gonna split the table up. So we have, so let's say we have A is 1, can we go up this way? Nope. B is 0, can we come up this way? Yep, we can, and so we can get there. Let's try the other way. A is 1, we can come down, B is 0, this gets stuck. So output here is going to be 0, because we can only connect one little low bit. Next bit. If we have 0 and 1, let's see how it works. So we can go up through here, yep, and we connect to the C. That's right. And so let's try it from the other way. So we have 0, it gets stuck here, cannot cross. So what do we have? We only have a connection from this path. Oh, we didn't even check this path, but because it's 1, we can't cross here. So here we have output of 0. 1 and 1, can we go up here? If it's 1, nope. Can we come up here? Nope. Can we come down here? 1, yep, we can come down. 1, come down. 1. Can we try it again for 0 and 0? Let's see what happens. If it's 0, 0 can come here. Nope. Yes, no, yeah, sorry, I said that wrong. If it's 0, it can come here. Yes, we can go across. 0 here, we can go across. 0 here does not work. 0 here does not work. So we connect to C and we get a 0. So it's, again, this is an AND gate, because we still have that 0, 100. Sorry, even if it's the wrong way around, let's let you guys cheat, because I'm not, I'm just explaining, just so you guys know. Do not condone cheating. Okay, let's go through this example. So this is quite an interesting one. Let's draw a little truth table again, because you know we like truth tables. So we're gonna have A, B, and out. And then we're gonna have 1 0 1 0 1 0 0 1. Let's go. So if we have 1 and 1, does it go through here? No, connection stops. Let's try 1 here. Does connection go through? Yep, so we can have an output there, and 1 here. Does the connection go down? No, it stops here. So we get an output 1 here. Let's try 0 and 0. Let's see what happens. So when we have 0 here, can it go up here? Yes, we can go up. Can we go up here? Yep, we can go up and we connect here. Let's try the other side. Can we come down here? Nope. Can we come down here? Yep. However, now we have an input of 1 and 0, so now we have a short. Can you see that? This shorted because we have too much current. We have current going in from here and current coming in from there. That means this is a no. Does not work. Let's try the next example. 1 and 0. So if we have 0 coming in here, does it go? Yeah. Does 1 go? Nope. Let's try 1 and 0 here. 1 comes down here. Yeah. And does the 0 come down here? Yeah. The 0 even comes here. So this one is a 1. Let's try 0 and 1 now. So 0 comes up. So sorry, 1 comes up here and it gets trapped. Sorry, let me just get rid of this stuff on here so you can see it. So 0 is coming up here. No, sorry, 1 is coming up here and it gets trapped here. It doesn't work. Let's try it the other way. So we have 0 here, does not work. We have it coming, what? 1 here, does not work. So we have nothing going to output C. Does that make sense? So we have nothing at all. So that means that we get undefined. So it's a bad circuit. We have we can keep that. The shorted here is when we have so we have a voltage coming in from the bottom and we have a voltage coming in from here. So we have 2 voltages for 1 output. And that's what equals a short. So a short is essentially when you blow a fuse. I don't know if you know what a fuse is, but that's not really important. Undefined means that there's no voltage from here coming up, and there's no voltage from here going down. So undefined means none. Shorted means 2 voltages. Different voltages. Sorry about my handwriting on this, by the way, guys. I know it's not the best, but you know it.